Hello everyone, my name is Junhyun Park.
I'm Hillary Koo.
And I'm Carolina Pavlik.
And our research topic this summer was investigating the extent to which discrepancies in SpO2 readings occur due to differences in skin pigmentation.
Our project focused on answering the following questions. To what extent do pulse oximeters work more falsely on individuals with darker skin tones, and what factors cause inaccurate pulse oximeter readings?
We hypothesized that skin pigmentation has an effect on the accuracies of pulse oximeters, with skin types 1 to 3 on the Fitzpatrick scale having more accurate readings than types 4 to 6. The inaccuracies in pulse oximeter readings are due to the different concentrations of melanin in people's skin and the lack of diversity in the testing population of pulse oximeters.
Pulse oximeters measure the level of SpO2, also known as oxygen saturation, in a person's arterial blood. They use a technique called photoplethysmography, where red and infrared light are shined through the finger, and software programs can determine the ratio of oxygenated blood based on light absorption levels received by a photodiode. We will also be referring to the Fitzpatrick scale, which is a method of numerically classifying human skin color based on its ability to burn or tan.
For our project, we used the data from Janine Pilcher's multi-center prospective observational study comparing arterial blood gas values to those obtained by pulse oximeters used in adult patients attending Australian and New Zealand hospitals. We then organized our data based on patient characteristics such as Fitzpatrick scale classification, gender, hospital location, and by the percent error between SpO2 and SaO2 readings. SpO2 is the oxygen saturation as determined by a pulse oximeter, and SaO2 is the oxygen saturation as measured by a blood analysis test.
As indicated in this graph, there were a higher amount of patients with Fitzpatrick skin types 1 through 3. There was only one patient for category 5 and then for category 6.
This graph shows the average percent error for each Fitzpatrick category, and a downtrend in percent errors seem to be visible as the Fitzpatrick scale increases, which actually disproves our hypothesis that skin types 1 to 3 would have more accurate readings than types 4 to 6.
One limitation of our project was that the research did not have a diverse pool of subjects, as patients were mostly types 1 through 4 on the Fitzpatrick scale, there was one type 5, and there were 0 type 6s, which could have accounted for the downtrend in percent errors as the Fitzpatrick scale increased. Another concern of ours was that the FDA requires that 2 or 15% of patients, whichever amount is larger, to be darkly pigmented, but fails to specify what constitutes darkly pigmented. Lastly, the Fitzpatrick scale classifies based on the ability to burn and tan, which may not always correlate with the expected skin pigmentation and does not correspond to any race.
Here is our pulse oximeter. It consists of an Arduino Uno R3, which connects the circuit to the computer. And as for the actual circuit, there is a red LED and an infrared LED which shines light on one side of the finger. And there is a photodiode which absorbs these lights and sends the signals to the computer for calculations.
As you can see here, I had an SpO2 reading of 95%.
In the future, we intend to obtain our own dataset with equal and larger numbers of individuals from each Fitzpatrick category. Then we will test our pulse oximeters. After consulting with pulse oximetry experts, we will develop additional recommendations for FDA requirements and modify our pulse oximeters until inaccuracies due to skin tone are eliminated.
Thank you.